So this video is going to focus on equations. In order to balance equations, you need to have the correct chemical formulas for both your reactants and products. If they aren't provided for you, make sure you follow your nomenclature rules in writing those formulas. We then want to make sure that we balance atoms on each side of our equation so that we have equal amounts of each element present. We do not change our chemical formulas. If we need to increase amounts of elements, we do it by multiplying them by a coefficient. So the subscripts stay the same. Coefficients can be increased. I encourage you to hold off on elements that are found in multiple places on the reactants and or the product side. So hydrogen often is found in more than one reactant or product. Same thing for oxygen. Those would be elements I would not do initially. I'll show you another way that I balance these in class as well, if that helps you. If you had me previously, you'll know what I'm talking about. If you have a polyatomic ion that is present in that form on both sides of the equation, you do not have to split up the polyatomic. You may treat it as a single unit, just like you would any other element. And then what I think is really awesome about balancing equations is you can always double check to make sure that your answers make sense. Don't be married to the fact that once you've balanced an element, you should never ever change it. Sometimes you may have to balance once and then you may have to rebalance. You typically should not have to do it more than that. But be prepared that if it's part of a compound, there's definitely a possibility that you may have to balance something multiple times before you get to the final properly balanced equation. You always want to simplify your coefficients. So if they all have a common factor, you want to divide by that common factor so you can show the simplest ratio. You do not have to put ones in front of chemical substances that you only need one unit of. You can if you wish, but you should never have zeros as coefficients because if you have a zero, then you don't have that reactant or product present. So in our first example here, we have KClO3 making KCl and O2. We see that to start with, potassium is balanced. You have one potassium on both sides, and you have one chlorine on both sides. But there are 3 oxygens in KClO3 and only 2 oxygens in O2. So to find something that both oxygens have in common, we're going to go to the multiple between them, which would be 6. By doing that, that means I'm going to need 3 of the oxygen molecules and 2 of the KClO3 formula units. We balanced K and Cl already, but now K and Cl are no longer in balance because I had to double KCl on the reactant side. It's a really simple fix. If I double it on the product side, I now have 2 Ks, 2 Cls, and 6 Os on both sides of the equation. In this particular one, some students will get a little anxious because oxygen is all over the place and you've got these polyatomics all over the place. Don't let those concern you too much. Take it one piece at a time. I start on the left and I look and see, is PB in one place on both sides? It is, and there's one on each, so we're good with that. I can look at nitrogen or I can look at nitrate. I'm going to talk about it in terms of nitrate because if you look, you see that NO3 is present on both the reactants and on the product side. I have 4 NO3s on the reactant side. I have 2 on the product side. So I need to increase how many nitrates I have on the product side. I need to have twice the amount that I have right now. So I'm going to double it. And when I double it, I don't just double the NO3. I have to double the whole compound that has NO3 with it. That means doubling calcium. Calcium happens to be the next element I was going to take a look at. I see it's in one place on both sides, but I have 2 calciums as products and only 1 as a reactant. So to get my calciums to be equal, I'm going to multiply the calcium sulfate on the reactant side by a coefficient of 2. The only thing I have left to look at now is the S and the O4. I see the SO4 is a unit on both sides of the equation, so I can look at it as a collective unit. I have 2 SO4s and PbSO42, the little 2 after SO4 as a subscript. And because I have a 2 as a coefficient in front of calcium sulfate, I actually have 2 SO4s on the reactant side. So this equation is now balanced, and I didn't have to try to do all the oxygens separately. However, if for some reason you chose to do N separate from O in NO3, and you chose to do S separate from O in SO4, I would probably still hold off on doing oxygen until the very end, since oxygen is a part of all 4 compounds. but the oxygens are going to balance out as well, whether you do them with the polyatomic units or whether you do them separately. Our next example, we have propene reacting with oxygen to make CO2 and H2O. I start with by having 3 carbons on the reactant side, so I'm going to need 3 carbons on the product side. Sorry about that. I have 6 hydrogens on the reactant side, so I'm going to need 6 hydrogens on the product side. I have 2. 2 times 3 would give me 6. Now if I take a look at my oxygens, I have 2 oxygens on the reactant side. I have 6 in my 3 CO2s, and I have 3 in my 3 H2Os for a total of 9. 9 and 2 do not divide evenly into one another, but if I take 9 and 2 together, the next number they both have in common is 18. So if I make oxygen go up to 18 on the left side, I need to make oxygen go up to 18 on the right side, which means doubling the CO2 on the right side from 3 to 6 and doubling the H2Os from 3 to 6. I already had the 18 O's on the reactant side. 6 times 2 gives me 12 O's in the 6 CO2s and 6 O's in the 6 H2Os, and 12 plus 6 then would also be equal to 18. So my O's are balanced, but because I had to double the C's, O2s, and the H2Os, my carbons and my hydrogens are no longer balanced. I would also need to double the 3 carbons and the 6 hydrogens in propene to now have 6 carbons on both sides, 12 hydrogens on both sides, and 18 oxygens on both sides. So this last one is a great example of balancing what you have at the time and being prepared to have to rebalance as a result of what you've had to balance before. Here we have a couple of word equations that we're going to take a look at. Remember that when you have compounds, you need to follow your rules for writing the formulas. Take care to write your formulas properly. Otherwise, trying to balance an equation with formulas that are written incorrectly can can be quite challenging. So lead IV nitrate, lead is +4, nitrate is -1, would become Pb parentheses NO3 parentheses 4. The and is going to represent my plus. Calcium sulfate, if I take a look, calcium is in group 2. Sulfate is SO4 -2, so they are equivalent in charge. I just get to sandwich these two together. 1 calcium for 1 sulfate. Reactimate is going to be my arrow. And now I have lead 4 again, and this time it's with sulfate. Well, lead is 4+, and we said sulfate is 2-, so I would actually need 2 of the sulfates to balance out 1 lead IV4. Pb parentheses SO4 parentheses 2. And then I have calcium nitrate. Calcium is in group 2. Nitrate is NO3 -1. So when I put those together, I would have 2 of the nitrates to balance out the calcium. Once I've written my formulas correctly, I can go through and balance. Pb is balanced already. I have 1 on both sides. I have 4 nitrates on the reactant side in PbNO3 while I only have 2 in calcium nitrate. 2 times 2 gives me my 4. Then I have my 2 calciums on the product side, and I only have 1 on the reactant side, so I would double calcium sulfate. Now I have 2 sulfates on the left, and I have 2 sulfates on the right. My final equation, I have aluminum and nitric acid are making aqueous aluminum nitrate and hydrogen gas. I'm not concerned about writing in states. We'll talk about that a little bit more in our, I think the second chapter going into the newer material. But right now we're just going to focus on writing these formulas. Because aluminum is an element and it's by itself, it's not one of the 7 diatomics, I just write its symbol, Al. Again, if you write the S, great. If you don't write the S, I'm not concerned. Nitric acid, y'all did learn acids in your first year class. We will spend time on acids after we review content from your first year class. So if I asked you a question like this on an exam, I would give you nitric acid. It's HNO3. So do not stress out about that again. They're going to combine to make aqueous aluminum nitrate. Aluminum is in group 13, so it's +3. It's an ionic compound. Any compound that starts with a metal is going to be an ionic compound. Nitrate, NO3 -1. So to balance out their charges, I would need 3 of the nitrates for every 1 aluminum. And then we have another element, hydrogen. Hydrogen is one of your 7 special diatomic elements, the Brinkelhoff elements. And whenever hydrogen is not a part of a compound and it's by itself in nature, it is written with a little 2 after it. These are the 4 formulas making up my reactants and products in this particular equation. To start with, if I take a look at aluminum, I see that I have 1 aluminum on both sides, so we're good on that front. You can go ahead and do hydrogen here if you wish, or you can do nitrate. It really makes no difference. The reason why you can go ahead and do hydrogen, it's only in one place on both sides of the equation. So if I was going to go ahead and do hydrogen, I have 2 hydrogens on the product side. I need 2 hydrogens on the reactant side, so hence the 2. I have 2 NO3s now on my reactant side, while I have 3 NO3s on my product side. We've run into this before, where you've got something balanced, but now another component of it is not balanced. To get the nitrates to balance, we need to find a factor they have in common between 2 and 3, which would be 6. With that in mind, I would need to multiply the 2 on the left by 3 to get to 6, and I would need to multiply the AlNO33 by 2 to get the nitrates up to 6. By changing the HNO3, I have changed the amount of hydrogens I have present. By changing aluminum nitrate, I've changed the amount of aluminum I have present. I have 2 aluminums on the product side, so now I need 2 aluminums on the reactant side. I have 6 hydrogen atoms on the reactant side, so I now need to multiply H2 by 3 to get the 6 hydrogens on the product side. Sorry for skipping ahead there.